The concept of the time value of money states that money in our hands now is worth more than money in the future. This is because we earn more interest on that money. So the sooner we receive it, better it is. The time value of money is applicable across various important finance and economics areas such as inflation, stock market, EMIs, etc. Even the concept of compound interest is linked with time value of money. Albert Einstein said, "Compound interest is the eighth wonder of the world. He who understands it earns it, he who doesn't pays it." In middle school, we were taught a maths calculation on compound interest. Amount is equal to principal multiplied by 1 plus rate raised to the power time. So simply, your value in the future is the present value of the principal grown at a certain rate while considering the time. Compounding essentially is earning interest on the interest. That leads to exponential growth. If we take the amount as future value and the principal as present value, we get future value equal to present value multiplied by 1 plus rate of return for each compounding period raised to the power number of compounding periods. Similarly, you can calculate present value, where present value is equal to future value divided by 1 plus r raised to the power n. Present value is the amount that you would pay today for a cash flow that comes in the future. Present value and future value are the basic principles of time value of money. Let's say if you plan to receive a sum of rupees 1 lakh at the end of 5 years, what is the present value of that amount, that is the value today? You can assume an interest rate of 7%. We can use the formula that is present value is equal to future value 1 lakh rupee divided by 1 plus r is 7%, raised to the power 5, which is 5 years. This gives us 71,298. So 1 lakh rupee that you have to receive after 5 years, the present value of that money is 71,298. Similarly, if you have rupees 1 lakh today and you're investing it for next 5 years, what is the future value? Again, you can assume 7% per annum. In this case, it is future value is equal to 1 lakh rupee present value multiplied by 1 plus 7% raised to the power 5. This gives us a value of 1,40,225. So 1 lakh rupee today invested for 5 years at 7% per annum will be equivalent to 1.4 lakhs. The future value represents what something is worth at some point in time in the future. Present value and future value can be calculated using Excel. When you enter equal to PV, present value formula will start, and FV, future value will start. Just to explain, when you enter PV, the first part is rate, which is 7%, NPER, number of period of compounding, so it was 5 years. PMT stands for payment, in our case it's 0. Future value is 1 lakh, so the present value is 71,298. Now we move to the other element, which is rate, that is rate of return. The rate of return is the percentage rate that is earned on a particular investment. This also relates to compounded annual growth rate. Often we are spoken about 1 lakh rupee will become 5 lakh in 25 years, but the question you should be asking is, what is my annual growth rate? Annual growth rate should be compared with a simple bank interest, and if it is more than the bank interest, then you should evaluate those investments, otherwise you should simply reject. So the formula for CAGR is end value divided by beginning value raised to the power 1 divided by n minus 1. So if we were to take the same example as 1 lakh rupee becoming 5 lakh rupee in 25 years, then it will be 5 lakh divided by 1 lakh raised to the power 1 divided by n is 25 years, minus 1. So this gives us 6.65% per annum. Now the other important area is PMT or periodic payments. So far I discussed future value, present value and rate. But in the formula there is also PMT which is mentioned in Excel. So PMT stands for any periodic payments. Let's say you're investing 1 lakh rupee today, but you're also investing say 10,000 rupees per month for next 5 years. What is the value after 5 years? So that is calculated using PMT. Let's use this PMT formula for calculating EMI. So let's say you take a car loan at 10% per annum. So it's 10% divided by 12, which is the monthly interest. And let's say you're taking the car loan for 60 months, that is 5 years. And you're taking a loan of say 7.5 lakh rupees. 15,935 rupees will be your EMI. Now you must train your mind to understand how quickly your capital can double. There is a shortcut to this compounding formula or these formulas combined together, which is a 72 divided by interest rate rule. So let's say you earn 7%. 72 divided by 7 is 10 years. Your capital doubles in 10 years. Similarly, had it been 10% per annum interest, then it is 72 divided by 10. So that becomes your capital doubles in 7 years. Let's say you are 25-year-old and you have a capital of 20 lakhs. If this capital were to grow at 15%, what do you think your capital would be when you turn 60? So every 5 years, which is 72 divided by 15, it's 4.8. So we can use approximate. Every 5 years, your capital doubles. So from 25 to 30, your 20 lakh becomes 40 lakhs. 30 to 35 becomes 80 lakhs. 40 years becomes 1.6 CR. 45 it becomes double of that, 3.2 CR. 50 years doubles 6.4 CR. 55 12.8 CR, and 60 years it becomes 25.6 crores. Now you can appreciate why compounding is called the eighth wonder of the world. You need to spend time to absorb the true essence of compounding in your life and investing. This is all what you need to calculate any aspect of your personal finance. So whether it is your retirement fund, whether to know how much funds do you need for your child's education 10 years down the line, or what value of retirement fund you need to have today to be financially free, or what would be the EMI of your house or car, or anything that is related to personal finance can be calculated through these basic formulas. I hope you like the video. Thank you for watching.